We are pleased to have Michael Wara there on your screen as our speaker today. As many of you know, Michael is a senior research scholar at the Woods Institute and director of the Climate and Energy Policy Program. I hope and I suspect many of you were able to join his webinar last Friday discussing a white paper he published looking at a three-pillared approach to mitigating our wildfire catastrophes in the coming decade. If not, I hope a recording is available soon. And Michael informally put in the chat a link to that white paper, which I think you would find very interesting. And I believe based on the title of his talk today, he'll be talking about something he talked about in the white paper as well as discussed on Friday. And he'll be talking about the Clean Air Act and wildfire smoke and what are the options. I hope we have some good options, Michael. And I'll turn it over to you.
Well, I'm looking at the participants on the webinar today. Thank you, Derek, for that introduction. And I'm looking at the participants on the webinar today and seeing a lot of people who are actually part of the team that is working on this right now. And I'll just say that a lot of what I'm going to say today is both the motivation and the work that's taking place in our smoke practicum right now. And I'm just going to try to provide some perspective on that and kind of why we're doing what we're doing and sort of how this integrates into broader goals for the state around wildfire, but also as an example of student-led policy relevant research in California. And I think that it's a really interesting case where we're hoping to have a big impact and really sort of start to change the conversation. And the protagonists in that really are people that are on this webinar. I see, John and Jill and Ada, Amanda. And so I'm really excited that you all could be here. Please, there'll be time hopefully for everyone to jump in and also share a perspective because there are people on this call who know a lot about what I'm going to be speaking about. So let me just pull up my slides. We'll get started. So I'm going to talk about the Clean Air Act and wildfire smoke and just kind of what the options are as I see it and how we can think about adapting an old law to a new and increasingly pressing situation. And the Clean Air Act was written at a time when wildfire was a big deal, but a much smaller deal than it is today. The 1970s were a time, kind of a moment in time when the fire suppression policies of the 20th century and the enormous investment that had been made in kind of militarization of firefighting on the part of the U.S. Forest Service and of CAL FIRE in the state of California were really paying dividends, right? Wildfire losses were at a minimum. We were perfecting the command and control and air support resources to really try to achieve the 10 by 10 policy, right? Every 10-acre fire discovered was out by 10 a.m. or fully contained by 10 a.m. the next day. And the Forest Service was kind of on target for achieving those goals at the time that a lot of the thinking around the Clean Air Act was taking shape in the 1960s. And the act we have in some ways reflects that, and the policies that we have in the state of California also reflect that, as well as the really enormous challenges that the state of California has faced for the last 50, 60 years in achieving healthy air. So what I'm going to talk about today is really thinking about how to integrate wildfire into what is certainly the most challenging air pollution context in the United States. So, changing our approach at the same time as we pay attention to the really pressing needs on the part of some communities in California to just have healthy air on a day-to-day basis. So I'm going to talk about PM 2.5 a little bit, which is the primary pollutant that is kind of most causes the most mortality, premature mortality associated with wildfire, and also is a place where we've made a tremendous amount of progress under the Clean Air Act over the last couple of decades. I'm going to talk about the system we currently have in the state of California for regulating smoke and at the federal level, and then just speculate a little bit about how the system might evolve in future and tell you a little bit about the research we're engaged in the smoke practicum to move that forward and to really accelerate change in an area that's becoming a huge concern for local, state, and federal policymakers. So what is the story with PM 2.5 and air quality? The first thing you say is PM 2.5 is a place where we've made a lot of progress. This is a figure that shows the average decrease in sort of the kind of most important kind of monitoring site for EPA compliance with ambient or national ambient air quality standards, which are the kind of the key regulatory standard that covers PM 2.5. And you can see that over the last 20 years, we have made a ton of progress in the United States. 43% decrease in the national average. There are large decreases really in all areas of the United States, with an important exception that I'll get to in a second. And this has avoided tens of thousands of premature deaths in the United States. Right? I mean, it's really impossible to overstate the value. Next to lead, which is, you know, the elimination of lead in gasoline was the most important and cost-effective step taken really to protect public health using environmental law ever. Improvements in particulate matter, and especially fine particulate matter, have provided the most benefits. And that's evident in this figure. These are enormous numbers of lives saved. And I'll show you a little bit more about that in a second. So the important caveat that I wanted to, that's important to understand is shown here in a sort of excerpt from a figure that Marshall Burke, myself, and others published in PNAS last year. This just shows that same in I'm gonna just try to do something fancy here and I'll use an arrow. Can everybody see my arrow on the figure? Great. So you can see the declining trend in PM 2.5 across regions marked in red there, but then you see the West and the Northwest kind of move upwards at the end of the figure, really after 2015. And what our paper showed is that you can really attribute that change in those two regions to wildfire smoke. This data doesn't include 2019 or 2020 data, but if you were to include those data, you would see this trend moving even further upward, as we all experienced living in California this past year. 2019 was a quiet year, but 2020 was worse than anything we've ever seen. And that's true both in California, Oregon, and Washington, and other parts of the Intermountain West as well. So what we're seeing is an elimination of the progress or a reversal of progress in the West. And it's also true that this pattern actually spreads over most of the continental United States. The wildfire fingerprint is present in particulate matter, even on the East Coast. And this is going to become a more significant problem under most, forecasts of climate change scenarios, because one of the phenomenon that's driving this really is drying associated with heating of the Western US. And this term that everyone focuses on these days is vapor pressure deficit. But the trends in vapor pressure deficit are quite alarming. And if we believe the mechanisms and the explanations that have been provided by climate scientists and meteorologists, and I would sort of tend to trust the experts on this one, they think that this is a really important driver of increased acreage burned, and so particulate matter emissions, and that VPD is likely to worsen faster than temperatures rise. So in essence, there's a kind of a log or a nonlinear relationship here, and so that means this problem can get worse quickly, like we've seen over the last 5 years. in California, and I apologize, this is an ARB figure and they mislabeled the axis, but it's the only one that their ARB is becoming increasingly concerned about PM 2.5 emissions from wildfire as well. This is a figure that shows the last 2 decades of wildfire emissions in California. This is in fact PM 2.5, not PM 10. The title of the figure is accurate. And what you can see is that, 420,000 short tons or so were emitted in 2018, which was an extraordinarily bad wildfire season, about 1.5 million acres burned. Of course, 4 million acres burned in California last year, or 4+ million acres. And so this is there does appear to be an upward trend in this data, and that's consistent with what we're seeing on the ground with fire. So, just to put some context on that, this is a figure. It's a complicated figure, but I want you to draw your eyes to a few things here. So this is an attempt to show from Tessem et al. 2019, using the EPA national emissions inventory data to sort of show where particulate matter comes from and regionally. And you can see that there are these different parts of this figure, which is complicated or broken up into different sources, and then the end use, and also the end user. But I want you to notice something, and this is characteristic of much thinking about PM 2.5 in the public health and environmental regulatory community. So there's all this analysis down here of all these sources: road dust, light duty gasoline vehicles, industrial, that's probably mostly the power sector, heavy duty agriculture. All these things are being focused on. Up here, Biogenic Wildfire International, which I'll just tell you is mostly wildfire, almost entirely wildfire, just gets no analysis. And notice this axis here, the vertical axis here is numbers of premature deaths in the United States per year in thousands, okay? So there's about 103,000 deaths, premature deaths associated with all the PM that's being analyzed, and about 30,000 deaths associated with wildfire. And wildfire is just kind of like outside the analysis here, right? And this is consistent with, this is we'll see why this is, but this is a really important fact in terms of the way that regulators and public health scholars have viewed wildfire smoke for a very long time. Another kind of indicator of concern, this just shows you the 20 highest area particulate pollution days in the Bay Area, where most of us live, since 1999. And this is as of early 2020. So this does not include the fires from 2020. And I guess I don't think I don't know if the Kincaid fire, which was a big Sonoma County fire that caused widespread air pollution impacts in 2019, is included in the state as well. But what you can see is that the 2017-2018 fires totally dominate signal for kind of acute particle pollution in the Bay Area over the last 2 decades. Nothing else even comes close. And the stuff that does come close dates from another era, right? Dates from a time when we had very different air regulation. And basically, we're back in that world. We're back in a world where multiple times a year, we're having very high pollution that is likely causing large numbers of premature death. Marshall Burke and Sam Hefneal went to the trouble of trying to estimate the numbers of premature deaths among seniors that were caused by the 2020 fires. We published a CEPR policy brief on this issue that was picked up by The Economist, and our best guess is that somewhere between 1,200 and 3,000 people died ultimately. And this is in the over 65 population, not everyone, from the PM 2.5 impacts associated with the wildfires in 2020. So this is a big deal. It's a big deal from a mortality perspective. It's undermining the progress, the really positive progress that we've made in reducing PM 2.5 impacts over the past 2 decades. So I'm going to shift gears now and talk about California the system we have, the air pollution regulatory system we have, that we need to think about modifying, because it's important to understand what you've got before you sort of pull up the hood and start tinkering. And I'll talk about the air quality challenges we face in California, and that's important to understand, because on the mind of any regulator, as you talk about modifying any part of the Clean Air Act or its implementation at the state level, is how will this affect the challenges I already have to deal with in my day job, right? How will this affect other aspects of the regulatory environment, the politics of regulation, which are extremely contentious? Today, just for example, there's a really important rule before the San Joaquin Air Pollution Control District around regulation of logistics centers, right? The warehouses where all of those Amazon vans emanate from that deliver prime goods to your doorstep in the pandemic. And those warehouses cause large pollution impacts, mostly because of all the truck traffic they generate. So this rule would regulate that truck traffic in various ways to try to reduce its PM 2.5 emissions. But the politics of that are enormously contentious, right? You're taking on Amazon and the warehouse owners and everybody who likes their inexpensive goods delivered, in a day or two. So what is that context? What is the regulation of burning that we currently have? And I'll explain why that's important. And then how is wildfire treated? Why is wildfire kind of outside the analysis if it threatens air quality, as I've been indicating that it in fact does? These are two maps that EPA produced in 2019 that show the air quality challenge, the two probably most difficult parts of the air quality challenge in California. One on the left, what you can see is PM 2.5 non-attainment areas based on a currently applicable standard, the 2012 standard. And I'll just draw, just recognize here that the San Joaquin Valley, right here, has some of the worst air quality in the country. Also problematic is the South Coast in Southern California. And the places where we have wildfire issues are Northern California here and the Sierra Nevada, right? So these are essentially upwind of this very challenging area for particulate matter. And that's going to complicate anything we might do that generates more particles that are at least subject to regulation. Similarly, this is on the right is a figure of ozone non-attainment areas using the more recent 2015 ambient air quality standard. And you can see that in California, we have some really significant ozone non-attainment. Ozone is not directly emitted by regulated sources, but precursors to ozone are, most importantly, nitrogen oxides and volatile organic carbons, which when combined, in the presence of each other and sunlight, produce ground level ozone. And you can see that we've got some very significant ozone attainment issues in exactly the same places, right? The South Coast and the San Joaquin Valley. And those challenges actually spread up into the Sacramento area and the Bay Area as well, although to a lesser degree. Wildfires, as I've discussed, emit a lot of PM 2.5. They also, emit the precursors to ozone. So this is challenging, right? What we're talking about are emission sources that threaten an already challenging air quality situation that is sickening and killing large numbers of children and adults in California. Just one statistic that I find particularly disturbing is that in several counties in the San Joaquin Valley, something approaching a third of children go to school with inhalers, right? We have very significant childhood asthma problems that are created and exacerbated by these air quality issues. And they raise enormous environmental justice concerns. And wildfire is going to make them worse. but so may prescribed fire, which is at least one of the most prominent proposals for what to do about the wildfire problem. And that brings me to another part of the system we have. The main way that the main cost-effective solution that we have for reducing the risk of catastrophic wildfires involves what you see on the right here, a prescribed fire practitioner lighting a forest floor on fire to burn off excess fuels. And that the idea with this kind of a fuel treatment is that it will allow forest fires that are wildfires that encounter this kind of terrain to burn on the forest floor at low intensity, producing less PM 2.5, less ozone precursor, and also keeping ecosystems intact. Of course, fire is a natural part of ecosystems in California, and the exclusion of fire from California forest lands is a big part of the reason that we have the challenges we face today. We forcibly removed the Native American tribes that used to burn the forest in a not dissimilar way to what this fire practitioner is doing. And we then utilized every means possible to keep fire out of those forests that might occur naturally or without human fire setting for the better part of 100 years. During that time, the Central Valley became an enormous agricultural center. Anyone who's driven across the valley knows this. And as a part of that, many farmers started to burn their fields. And agricultural burning, in the fall, typically to burn off stubble, agricultural waste. And today, many farmers burn the trimmings from orchard crops as well, which have become a major source of agricultural burning in the Central Valley as more and more acreage is converted to these kind of multi-year crops that are more drought resistant as opposed to annuals that are more subject to kind of risks with water and are lower value. So this is a picture on the left of what that ag burning typically looks like. And it used to be a major producer, and still is to some degree, a major source of PM 2.5 and ozone precursors in the Central Valley. As particulate matter standards after 1997, as PM 2.5 standards were phased in, that was the date at which the first PM 2.5 ambient air quality standard was set. States and localities that had significant attainment concerns phased in limitations on ag burning. At the time, wildfire was much less of a big issue in California. Prescribed fire was not utilized on a widespread basis to manage fuel risks. And so when the Air Resources Board wrote a regulation to cover this kind of activity, they wrote a regulation that covered agricultural burning, the burning of pasture lands, and prescribed fire as one rule. And that regulation exists to this day and basically treats all of these practices as sort of like farming, right? And you could imagine like treating a forest a little bit like a farm, right? That timber plantation is kind of a farm with a long crop rotation. And prescribed fire is utilized on timber plantations to maximize economic returns and lower risk. And that's especially true in the southeastern United States, where there's widespread use of prescribed fire on private timberlands. ARB regulated all three sources with one rule that basically determines how the state system that allows or does not allow burning functions to this day. The rule was primarily targeted, however, at ag burning, not at prescribed fire. And to the degree that it targeted prescribed fire, conceived of prescribed fire as treating, as something that would be conducted to benefit the private landowner where the fire occurred, but not as something that might reduce emissions downwind and reduce exposure of sensitive health receptors, and so create a public benefit in addition to a private one. The other element in the system we have that is really important to understand is a section of the Clean Air Act that governs which data states have to report to federal regulators for purposes of determining whether they have complied with ambient air quality standards. Now, remember here, ARB and the state of California is requiring a permit if and when a farmer wants to burn their field, if and when a forester wants to utilize prescribed fire as a tool to burn fuels in a forest. Air permits are required. Those air permits are designed to achieve attainment with the ambient air quality standards. So in addition, the Clean Air Act, in managing the data monitoring and reporting that states do for purposes of determining whether they've complied with ambient air quality standards, has this provision regarding exceptional events, where it defines an exceptional event as something that affects air quality, isn't reasonably controllable or preventable, is an event caused by human activity that is unlikely to recur at a particular location, or a natural event, and is determined by the administrator to qualify to be an exceptional event. So what this boils down to is a statement that when states report their data to EPA, for EPA to determine whether they've complied with the Clean Air Act, if there are data points that are bad, that would create non-compliance, non-attainment in the terms of the Clean Air Act due to a quote unquote natural event that is not reasonably controllable or preventable, they can throw that data out. In practice, what this has meant is that states whose attainment with PM 2.5 or ozone would be threatened by by emissions caused by a wildfire can throw the wildfire influence data out when they report it to EPA. So on the one hand, we have a situation where air permits are required for prescribed fire, and on the other hand, we have a context in which the wildfires that those prescribed fires might prevent or reduce the impacts of don't count for emissions compliance under the Clean Air Act. That asymmetry is a big part of what we're working to better understand and ultimately create workable solutions to undo under the Clean Air Act. So how might the system evolve? This is a picture of the creek fire during the day when it blew up. It produced a pyrocumulus cloud in 2020 that was about 50,000 feet tall, well into the stratosphere. It had an area burning detected by infrared satellite detect that was extended over about 10 square miles. And burning simultaneously. So not, typically forest fires burn with a flame front and they advance across terrain. In the case of the creek fire, essentially a large section of forest in the southern Sierra Nevada ignited simultaneously because of weather conditions and the fact that there were tons of dead trees that had been killed by beetle infestation during the last drought, during the multi-year drought. These trees ignited, caused this firestorm. The folks that have been looking at it sort of compare it less to forest fire and more to the Tokyo firebombing as an analogy for kind of what the conditions that were observed. So, a big question is like how to avoid these kinds of outcomes. And for many years before the burning of the area in the region of the creek fire, the Forest Service had been saying, the Forest Service and California, Governor Brown, Governor Newsom, after him, had been saying, we need to do fuels management. We want to evolve towards a situation where we're doing 1 million acres a year of field treatments. And the goal here would be, the reason to do that would be to minimize the risk of these kinds of catastrophic fires by restoring forest lands to something like their natural fire regime. Natural, I would include within that framework the cultural burning that Native American tribes conducted for millennia prior to European conquest of California, and then to so minimize risks of catastrophic fire, and also work to minimize smoke and PM impacts from catastrophic fire. But of course, we're a long way from that goal. I don't know if anyone in this talk was able to attend Rebecca Miller's thesis earlier today, but she showed a bunch of data around prescribed fire acreage that's actually being burned in California, and we're down around 50,000 acres right now. I think maybe by now in this talk, you're not surprised by this slide. There's a challenge here around implementation, getting the money, how we would scale up the workforce to do 1 million acres a year, how to do that in an ecologically sensitive way that actually restores ecosystems and doesn't just harm them in a different way. There are an enormous number of challenges, implementation challenges here. But another challenge is that it would be basically illegal under the Clean Air Act. And the current framework doesn't value the benefits of prescribed fire really in any way. It assumes that if a landowner is conducting a prescribed fire on their land, they're doing it for private benefit, and just like any other private source of air pollution, it's regulated as such. The current air quality framework, if we were to try to burn anything like 1 million acres per year, it would be less impactful than high intensity wildfire burning a similar acreage per year in terms of PM. But I think there's no question that it would violate ambient air quality standards. It would cause widespread violation of ambient air quality standards, even beyond the levels that they're being violated today. And in addition, the current design of the implementation of this exceptional events doctrine, while it does theoretically allow for the use of exceptional events to cover prescribed fire, only allows for these determinations to be made for single events, not a program of activities. And the thing about catastrophic wildfires is they are large individual events, like the one in this picture, where you might go through the trouble to do an exceptional events determination, which I won't bore you with the details, but it's complicated. There are lawyers and air quality modelers involved. It's not cheap. There's public process involved as well. Prescribed fire, by contrast, in order to keep it safe, is kind of by definition pretty small. Like the biggest prescribed fires are a couple hundred acres. And usually they're much smaller than that. So the idea that we're going to be doing these kinds of burdensome exceptional events determinations isn't realistic. So what are we doing to move the ball forward? The work being done at Stanford in the smoke policy practicum really builds on work that the climate and energy policy program has been doing for the last couple of years, trying to understand this paradigm, the regulatory paradigm we have, and investigate where we might make changes to improve the situation. Asymmetry that I spoke about with respect to the way that wildfire versus prescribed fire is treated under the Clean Air Act has been recognized for about a decade. But the proposals that have been made to modify it mostly involve treating wildfire as a pollution source under the Clean Air Act. And I think it's important to understand that that's kind of a non-starter in California and in many parts of the Western United States, because it would mean that essentially, well, many parts of the West would be in severe non-attainment with respect to particulate matter. And that would mean that, I won't say it's impossible, but it would make it incredibly difficult and burdensome to build any new sources, and anything that would be a new source of particulate matter within those jurisdictions. So it would mean that because of wildfire, you could never site a backup generator in large parts of California. And so air regulators are understandably reluctant to take that step. So our question is, are there other ways to approach this problem that could solve for the politics, preserve the ability to treat other regulated sources, the other part of that Sankey diagram that I showed you, in the way that they're treated under the Clean Air Act, but restore some balance between prescribed fire and wildfire? And part of that is legal analysis. Part of it is really developing the beginnings of a quantitative regulatory impact assessment, a cost benefit analysis of what a scenario with a lot of prescribed fire would look like. And I'll just say that the students that we have in the class are really an interesting mix of PhD students, scientists, young scientists, and young lawyers that have come together to work collaboratively to try to solve this problem and make progress. So on the legal analysis side, we're looking really carefully right now at how the rule is actually applied in practice, and what the advantages might be to essentially rewriting California's application or California's regulatory framework for all of these types of intentional burning to separate the kinds of burning that have public benefits from the kinds that have solely private benefits, right? So you could imagine, instead of having one rule, you might have a rule for ag, and maybe ag and pasture lands, and a separate rule for public benefit prescribed fire in forested areas of the state. And that could significantly alter the calculus that drives whether a particular burn is allowed to go or not. We're also looking carefully in trying to understand how the rule is applied in practice, at whether there are other limiters in the system that could be removed. In particular, are there simplifications that could be made in terms of how permits are issued? Is staffing a limiter in important respects? I'm trying to gather data on this, because the reality is, like most kind of permitting issues, there's very little data. There's no statewide data collection about these kinds of issues. There is a statewide database to look at where air permits have been issued, but even that is not complete. And what's really important about it is it only covers the universe of permits that are issued, not the universe of burns that might occur, but that don't occur because the permitting system is burdensome or is limiting in some other way. So we're really trying to wrap our arms around that and understand it. Separately, we're looking at the federal situation and trying to ask a question that was really posed for us by and I should have mentioned this initially, posed for us by our quasi-clients in the class. The Smoke Practicum is working and collaborating with the Karuk tribe in Northern California to try to understand their concerns around the limitations they face on the use of cultural burning and prescribed burning. They're a Native American tribe that for millennia has burned the landscape to, as they put it, give gifts back to the land so that the land can give gifts to them as well. And they're really important cultural resources that are enhanced by cultural burning. At the same time, the tribe owns large acreage of forest lands and wants to see it managed responsibly and effectively. So they're also interested in using prescribed fire outside of the cultural burning context. And so one of the things that they say to us is that what they really want to do is there's sort of a month of time or 2 months of time, a season, when particular changes are happening on the landscape, and they'd like to be able to practice the kinds of land management that they understand and have experience with for millennia that produce ecosystem health. But they have to get these individual permits to do every little thing. And so, one aspect of the federal analysis that we're looking at is, first, how these exceptional events determinations are used in practice, how they, whether the context in which they have been used, in particular, whether they have ever been used to allow a prescribed fire to occur, or whether what's really going on is that prescribed fire is being kept limited because of because it's running into the need for air districts to comply with ambient air quality standards. And then whether we could move under the current law without having to actually ask Congress to change the law, but only asking EPA to change regulation or guidance, whether we could move toward a sort of programmatic use of exceptional events. And this is the idea where you would ask EPA for a determination that a program of activities, say a month in which many prescribed fires occurred in a particular area, could count as an exceptional event. Much in the same way that you might say, a series of lightning strikes in a national forest that ignites a number of fires might lead to an exceptional event, especially once those fires burn together and form a complex. The other issue that we're looking at is how all of this might interact with both ozone and PM non-attainment in the context of exceptional events. This is particularly complex for ozone, because as I mentioned, ground level ozone is formed by chemistry in the atmosphere from, where precursors react to form the ozone molecules. And the challenge there is kind of causality, right? If there are many sources of ozone, how can you prove that non-attainment occurred because of these protective these actions that are being taken to minimize ozone in future? And I think it's going to be particularly challenging, but this is where we need to go in order to move the field forward and hopefully move toward larger scale deployment of risk reduction strategies that we believe to be effective. So on the other piece of the work that we're doing in the smoke practicum involves what I described as a regulatory impact assessment or a cost benefit analysis. And here, the basic idea is to try to sketch out, and this is something that strangely, even though these goals have been presented as the consensus goals by the state of California and the federal government, no one has done. The goal here is to create a conceptual model of future wildfire and a conceptual model of prescribed fire intervention at the scale that the state of California and the federal government are proposing, doing something like 1 million acres a year of field treatment, mostly using prescribed fire because that is the cheapest treatment, right? Prescribed fire costs about $1,000 an acre. Mechanical treatments are much more expensive. So in order to do that, in order to compare those two states of the world where, say, for a decade, California, 1 million acres of California lands are subject to prescribed fire. And for a decade, we just let wildfire play out as it might in California. We need to develop emission scenarios for each of these states of the world. And of course, in the prescribed fire alternative, wildfires also occur, but prescribed fire over time reduces the incidence of wildfire. So there's sort of an interaction between the untreated and the treated outcomes. We need to develop scenarios for that. And then, and that's something that we're in the process of exploring how to do. And then ideally scenarios that can be inputted into simplified air quality or air transport and health impact models to value the potential the difference between a wildfire only scenario and a scenario where we intervene to reduce risk by large scale field treatments. And what I'd say is mostly at this point, we have a lot of questions more than answers. And I tried to write down some. One basic question is, how much forest is there to manage that hasn't already burned? Chris Field mentioned, I think at a certain point in this seminar that maybe all the fuel will just burn up, right? If we stay on track, if we keep burning 4 million acres a year, there isn't that much forest left in California. We will treat all the forests with wildfire in relatively short order. And that is certainly possible. But I think a first step in our analysis is just to say, what's left that hasn't burned? About 10.7 million acres have burned in the last 10 years in California out of a total of approximately 30, leaving approximately 20 left. Where is it? How does it, is there spatial complexity in that? What does that imply for the use of fuel treatments? A second important question as we move toward trying to quantify kind of a hypothetical emission scenario as opposed to measuring emissions from the past is how much emissions occur when prescribed fire or wildfire burns through a forested landscape. And there's actually surprisingly little information about this. What we want to know is for a ton of fuel combusted, how much PM 2.5 is emitted into the air, right? What is the emissions factor? And the data here is not as good as one would hope. We are working on getting to answers on kind of what emissions factors, what the uncertainty band is in emissions factors associated with prescribed fire and wildfire. It does appear to be the case that prescribed fire emits substantially less, but how much less and what are the uncertainty bands around that is still something that we're working on. Another sort of set of really complicated questions involves the effectiveness of prescribed fire. And one question would be, what are the odds that a prescribed fire treatment fails to work, in the sense that you might cause emissions from prescribed fire and then have a wildfire like the Creek Fire encounter the treated lands and decimate them anyway, right? And we might even think that's becoming more likely because of climate change. So what can we understand about the effectiveness, and how does it depend on what treatment is utilized? And there's really interesting quantitative science around combustion in forests that's coming out around that. Finally, how long and does a prescribed fire treatment last, or how fast does it decay? Sorry for the typos here. Right, so what is can we expect that if we treat forest that the prescribed fire treatment will last a decade? Or is it half as effective in a decade, or only 25% as effective? And that's something where we're trying to learn more so that we can build this scenario and then create enough information to use simplified air quality models. So in conclusion, PM 2.5 is a pollutant where we've made a ton of progress over the last 2 decades, but our progress is being undermined principally by wildfire and climate change. The system we have for regulating smoke isn't fit to purpose anymore, right? It was created at a time when wildfire was a much smaller problem and where other kinds of particulate emissions were much bigger problems. And now we face the reverse. We need to think about how the system might evolve, and in principle to allow much greater use of prescribed fire, but without breaking the elements of the system that are producing progress on the sort of point sources and mobile sources of particulate emissions like diesel soot. And at Stanford, we're engaged in a kind of multidisciplinary student-led effort to make progress on these questions. And I would say that there's a large set of stakeholders in California that are really paying attention to the work that we're doing and are excited to see our results. Thanks very much, and I'm happy to take questions.
Thank you, Michael. Really appreciate much food for thought. And I just want to acknowledge we are at 1:20 already. And if Michael's willing to stick around, I'd like to stick around to 1:30 for people that want to stick around to at least field some questions and have some discussion until 1:30. So thank you for attending. And anyone have a question or comment for Michael? He spoke on many important things.
I have a question. Thank you for a really great talk. I'm really interested in the chemical composition of PM 2.5. So is the Smoke Policy Consortium also considering the differences in chemical composition of PM 2.5 from these various sources like prescribed fires and wildfires?
At this point, we are not. Although what I'd say is that the one place where air quality models are quite flexible is in the health impact functions that are utilized to move from emissions estimates to health impacts and then valuation of those impacts. And so, to my knowledge, there aren't wildfire specific kind of health impact functions that are available yet, but as they become available, I think that'll be really important. And certainly there's emerging evidence that wildfire smoke is different and than diesel PM, and potentially not in a good way. And that also the size distribution, size classes below 2.5 microns may make wildfire smoke worse as well. That there's a larger concentration of sub 1 micron particles than there is in diesel PM. So it's something I'm paying attention to, but I think we're not quite ready to move it into the policy space yet, because it's an area of rapidly developing knowledge.
Awesome, thank you.
Of course.
Great. Other questions or comments? Well, I'll give you one. Like I've heard this number bandied around a lot. This 1 million acres of prescribed fire. Do you have any insight to where that comes from? Because that's like 3%, right, of the forests, right? So you were asking like what you ended by saying here. Oh, it might take. Does it last a decade? So it's like, okay, if you rotate that through, if I do the forests as the count, that's once every 30 years. So where did the 1 million come from? Because it's a lot. But is it enough? And where did the 1 million come from? Or is it just a nice target number?
I think it's a nice number, to be honest. When I was on the wildfire commission for the state, we had the head of CAL FIRE come and testify before us. And he talked about these very ambitious targets. And I asked him not so much where the number came from, but what his plans were to get from 50,000 acres to 500,000 acres, right? Because it's 500, 500, right? The feds do 500 and CAL FIRE does 500. And he diplomatically avoided answering the question. And so I think that's a nice round number that's very big. But it doesn't have a ton of scientific basis, at least on the part of the people that maybe said it. On the other hand, what if you believe that? I think there are ways to sort of game out the numbers where if we were to burn or if we were to do field treatments on 1 million acres a year and wildfires continue to occur, that we could get in 10 years to a situation where most forest land in California had either burned or been treated, and you'd have a much lower risk. Now, of course, this is the Golden Gate Bridge problem, right? Where as soon as you get done painting one end, you have to go back to the other and start over. And then I think your question is a really good one. Like, is the 1 million acres enough on a sustained basis? Yeah. I think right now, given where we are in the regulatory paradigm, it's just not, we're so far away from being allowed to do that. And frankly, like justifying that it would be a good idea, that we need to, I mean, there are intuitions that it would be. When you talk to land managers, they believe firmly that it would be. When you talk to the tribes, they believe firmly, and I frankly trust them maybe more than the Forest Service on this one. But it's before we get there, we need to understand, what that means for people's lungs and whether it would make it better.
Yeah, I guess that's what I was sort of alluding to. I mean, 1 million sounds like a big number, but it might not be enough. So,
Yeah.
and I don't know if the science is there yet to say, oh, what's the critical threshold we need to make a dent and actually drop down the, the catastrophic wildfire. So like, if you do 500,000, maybe that's really such a small subset that you're still going to get most of the fires we got last year. I don't know. I'm not trying to be a pessimist, but I'm wondering, because 1 million does sound like a lot, but then it seems small compared to 30. So
yeah, it is. And I think the to get to 1 million acres, assuming that's a worthy goal, and that is an assumption. I want to emphasize that, there are a lot of questions we would need to answer in terms of the environmental impacts associated with doing that, especially the ecological impacts, right? This is a major intervention in California forests that are populated by many, many endangered species. But to get there, I think would require getting over a set of hurdles in terms of culture change and cultural change in California, regulators, but just normal people being comfortable with having smoke in the air in February, March, and April, right? In a way that we don't at present. That if we could achieve that, it would be much easier to have a conversation about whether 1 or 800,000 acres or 1.2 million acres is the right number.
fair enough.
It's a factor of 10 to 20 increase over where we are now. And then the question of 20 or 30% more is easier.
Yeah, fair enough. Anyone else have a last question to ask of Michael? This has been just a great discussion, and I know I have a lot of other questions looming in my mind here, but I hope you really appreciated his
Can I
insights
just
today.
make one pitch, because this is the data seminar? The one place where that gets to your question, Derek, is targeting. Right now, the CAL FIRE targeting, I am not a big data person, and I could improve on how CAL FIRE plan targets the field treatments that do get done, and the analysis that they do to assess the value of different locational specifications. And I think there is an enormous big data challenge around figuring out how to target these interventions and investments in order to maximize payoffs across a variety of dimensions, right? Structure loss and loss of life, fire suppression cost, and downwind smoke impacts. And it is not simple. There's enormous geospatial complexity in terms of the forests. And then you have to add in the built environment that might be impacted by a fire and the downwind health receptors, right? The people in, say, the Sacramento Valley, in Sacramento or in Bakersfield, that are going to be impacted if the smoke drifts over them and their kids have to go to school. So there's a really interesting optimization problem here and targeting problem that really is not addressed, and I think would be enormously valuable if we were to do it.
Wow, thank you, Michael. That was a fantastic way to close off our discussion today. Thanks for everyone's attendance. Just want to remind you, we're continuing for 3 more weeks. Sam and Marshall's work, which Michael talked about today, will be on display next Monday. So I hope you'll join us then. Have a great afternoon, and thank you again, Michael. Really appreciate it.
Thanks for having me.